This next section is from 13.4, page 462 in the textbook, and it has to do with graphing circular functions, or maybe you're thinking circles when you think circular functions, but think about how trig identities, trig functions, operate in a unit circle, and that's kind of the circular functions, or the repeating functions that we see in trig functions. So since we know a lot of the values for both sine and cosine, graphing is actually not too difficult, even without the use of a calculator. Think about the values that you actually know. So to begin, we're actually just going to look at the sine function. And think about the angles that you do know. This one should be fairly obvious. And to help you, think about, since sine is the same thing as the y value, so sine theta is the same thing as the y value in a circular unit circle. What is the y value when the angle is 0? Well, that is 0. So when we create a sine function of the angle versus the value, what we're able to do is start right in the middle. So the sine function actually starts directly in the center. So let's think about some of the other angles that we know. We should know the sine of 30 degrees. That equals 1 over 2. Should know the sine, 30 degrees, not 30 degrees, 45 degrees is 1 over root 2. Should probably know 60 degrees by now is root 3 over 2. And you probably know 90 degrees, it equals 1. As we move over to the other side, we see that the sine of 120 degrees is very similar to the sine of 60 degrees. The only difference is this becomes negative 3 over 2. And then we go to sine of 135, very similar to the sine of 45, but we have, oh sorry, these are all positive values still. Y value is still positive. 3 over half, so these continue to actually have the same number, right down to the sine of 150 equals 1 over 2, and then when we get to 180, it's the same thing as 0. As we get past 180 to like 210, we have the same value as 30, the only difference is we get a negative sign there. So as it goes through 225, we got negative 1 over root 2. And we can probably continue this for a while, but what we eventually start to see is a bit of a pattern. It appears it's the same ratios, the only difference is that they're going from positive to negative, or from 0 to positive, and positive to 0, and then negative. And there's the rest of the values that fall in there. So let's try to graph this. So we start with 0, 0, and as we go to, let's say 30 degrees, we have a rise that ends up being at 1/2. And then the next value that we have goes up to 1 over root 2. So that's just a little bit more. And we eventually get up to about 1. I could draw that. 1, and then it starts coming back down again, and it comes back down roughly in the same spots, then begins to get negative. So, and as you follow this along, what you notice as we get to 2 pi over here, so here was our 0, here was our 180, and here was our 360 degrees. We actually hit 0 at all 3 of those spots. And as we get past it, 2 pi or 360 degrees, we notice that the pattern begins repeating itself again. Now that also happens going in the negative direction. If you have a negative angle, say negative 30 degrees, what you get is negative 1/2. So as we go in this direction, the pattern also repeats itself. And we get what is basically a periodic motion. Now, features of this are things like, well, where does sine actually begin? And some key features would be sine begins at the origin. You would want to note that sine gets as high as 1. So the sine of whatever the angle is goes from negative 1 and goes all the way up to 1. Other things that you would want to note is that the period of this, or the amount of time it takes to repeat itself, is actually 2 pi, or 360 degrees. That's how long it takes before the motion begins to repeat itself again. So these are important observations. I'm going to do another screencast for cosine, but this repeating pattern that you see and some of those key features that I just noted there should be things that you're aware of. If you're unsure about it, graph it on a calculator and see what exactly happens. If you play around with some of the numbers as well, like the coefficient for sine theta, or maybe sine of 2 theta, or sine of theta minus 4, what happens to the graph? So play around on your graphing calculator and see what happens.